This is an extension video on how to transform a given graph that might not be a V-shape or a U-shape. So in this one, this is going to be the parent graph for this whole page. So the first thing I did was I just listed the points as they're given. So this was, left 3, down 2. So that's why that's -2 and so on. Next, we want to state the domain and range. Remember that from last unit. So the x's get as far left as -3. So I want to put a -3 here. And then as far right as 1, 2, 3, 4. Okay. And the range is as low as -2. And as high as +2. Okay. So again, we're going to use this parent for everything else. So looking at this first one, it's 2f of x. So it's going to take and multiply all the y values of our parent by 2. It should also stretch us vertically, which is actually going to take us above and below the x-axis as we stretch. So let's see what happens. So I'm going to take 2 times all of the outputs. So I get -4, 4, 4, -2, -2, and 0, because 0 times 2 is 0. There is no inside change, so the x's are going to stay the same. So now when we graph this, we are going to get the same looking picture, but it's going to be stretched, and it's going to be stretched vertically away from the x-axis. Also notice that the domain does not change because we still have the boundary of -3 and +4. But the range doubled in size. So now we're 4 above and 4 below. And we can see that here. We get as high as 4 and as low as -4. And our description is that we expanded away from the x-axis. So stretch from the x-axis. Stretch away from x-axis. Okay. I'll do one more example, and then I'll expect that you can do the rest of this paper. I'll do one of the hard ones here on the bottom. So let's look at this one. So on this one, I'm going to have a couple changes. I'm going to have an inside change. So this is going to take us right 3. Okay, and let's do that one first. So if I actually move all of my original x's, if I move all of these to the right 3, instead of subtracting 3, I actually have to do the opposite. I have to add 3. So I'm going to take all these x's and add 3 to them. So I get 0, 1, 3, 5, 6, and 7. So that will move us to the right 3. And then the outside changes I have to do in PEMDAS order. So I'm going to take all my original y values, multiply them by -2, and then add 1. So for these, so if I wanted to kind of make a note to myself, for these I added 3 to get those to the original. And then over here I'm going to times by -2, then add 1. Notice how these are not opposite, whereas this is opposite of that. So let's do that real quick. So again, I'm going to take these y values up here, multiply them all by -2, and then also add 1. So -2 times -2 is +4, but if I add 1, I get 5. +2 times -2 is -4, plus 1 is -3. Again, should get the same result because I started in the same spot. -1 times -2 is +2, plus 1 is 3. This one's also 3. the same start, and 0 times -2 is 0, plus 1 is 1. Okay, now if I graph this, I should see 4 changes. I should see us sliding to the right 3, I should see us flipping, I should see us stretching, and I should see us going up 1. So let's see what happens. All right, so 0, 5, 1, -3, 3, -3, 5, 3, 6, 3, 7, 1 is right there about. So if I do this, so let's kind of take a look at this picture. So this compared to the original, yep, it looks like it flipped. I can see that, flipped over. It also looks vertically stretched, so that's that 2. We can see it move to the right, so that's that -3 on the inside. And then we also can see it slightly moved up 1. That's a little harder to see it moving up 1 from there, but that did happen. So now look at the domain and range. The domain is the lowest x, so 0, to the highest x of 7. And the range is lowest y, -3, to the highest y of 5. And the description, let's just go left to right describing the changes. So we had a flip, stretch away from the x-axis, but we don't have to write that. We don't have a lot of space. Right 3 and up 1. So that's how you do this. So the expectation now is that you can do the rest.